Hello, today we're going to be learning about vectors. By the end of this lesson, you should be able to distinguish between scalars and vectors, and you should be able to add and subtract vectors geometrically. First off, we need to figure out what a vector is. A vector is just a directed line segment. So it usually represents some sort of force. So like an object will be going in this direction, and the length of that vector determines on how strong or how fast or how much force it will be going in that direction. So a vector that is long will have more force than, say, this small vector. Maybe I'll call it u. So a vector is described by it has a head, and that's the direction it's going, and its tail, and that's where it begins. Now a vector has both magnitude and direction. So it has a big size, and then it has like some angle that it's going to go off at. So say this vector A, it's as strong as it is long, and it's going up and to the right. Now a scalar just has size, such as distance, time, volume. So if I wanted to just describe this as a scalar, I might be able to say this is 8 units long. So the length of it, say if this is 8 units long, we'll call the magnitude. That's a scalar because it's just measuring the distance. But when I draw a vector, I get both the magnitude and its direction. Now when we write magnitude, what we write is this A with absolute bars, absolute value bars. So it would be magnitude of A is 8 units. I think I have that on the next slide. The absolute value, or magnitude of the vector, is the scalar quantity equal to its length. Now, two vectors are equal if and only if they have the same magnitude and same direction. So if I take this and bring it over here, these would be equal vectors. But as soon as I start and change the direction, even though their magnitudes still stay the same, these are not considered equal vectors because they aren't going in the same direction, where now they are equal vectors. So congruent vectors are same magnitude and same direction. Opposite vectors are same magnitude, but they're going in the exact opposite direction. So we switch one of their heads and tails around. All right, so that's what a scalar, the difference between a scalar and a vector is a scalar just has a unit and a vector has unit and direction. Now, when we get to adding vectors, say if I have these vectors a and b, it's different than scalar addition. Now, scalar addition, if I have 3 centimeters plus 4 centimeters, that's 3 centimeters long. If I add 4 centimeters to it, I just put it at the end, and that is a total of 7 centimeters. Vector addition isn't quite that simple, but it has the same concept. The sum of a plus b, I take the vector from the beginning of a to the end of b, if b is placed at the head of a. Pretty confusing definition, but what it's saying is I take my vector b and I put it at the end of vector a. Now the sum of a plus b is if I go from the beginning of a all the way to the end of b. So this vector right here is the vector of a plus the vector of b. Now what this represents, so if we want to think about this in more of a real world situation, if a plane is flying in this direction and a wind is blowing in this direction, the result that the plane would fly would be this a plus b. Now let's do a couple examples. Now a plus b, I take vector a I put B at the end of vector A, and now I draw from the beginning of A to the end of B. So A plus B is this vector right here. Now, negative B, I just take B and I have to do the opposite. So if this is B, I have to flip it around. So if I just do this and forget that this exists, this would be negative B. It's just like B, but it's going in the opposite direction. Now if I multiply, so if I have 2 times A, I'm going to take vector A, I'm going to put A at the end of A. So this right here is vector 2A. It's twice as long. Now A minus B, that's like A plus negative B. So I would take A and my negative B, if I could spin this around. So what I'll do is I'll go up in this direction. So that would be my negative B. So I'll take this whole thing, put it at the end. So I have A, negative B. And so we go from the beginning of A to the end of negative B. And that's A minus B. All right. Now I want you to take a second, and here are 2 new vectors, and I want you to find all of these values. So pause the video and see how you can do on your own. When you're ready, start the video back up. All right, so if I was going to do A plus B, I would do A. Oh, I should clone these first. So I'll take A, put B at the end of A. So A plus B goes from the beginning of A to the end of B. So that would be A plus B. Negative A, I'll just draw this in the opposite direction and pull it down here. And that's my negative A. Negative 2B, I'll just start here and go in the opposite direction. And I'll have 2 of those. So I'll put this at the end. And now that's negative 2B. And now if I have A minus 2B, I'm going to take A, and I'm going to put 2 negative B's on. And so now I have to go from the beginning of A to the end of 2B. So this vector right here is A minus 2B. All right, now we're going to look at a diagram with a bunch of vectors on here. If I have AB plus BC, I'll trace this out. If I have AB plus BC, what vector is this plus this? Hopefully you can see it is AC. So that would be vector AC. Now if we look at FB, here maybe I'll erase the blue ones, not the other ones. So if we have FB and DB, or BD, like this. So FB plus BD, that's going to be FD. So now we have EB, so I just have to move this. EB plus BC plus CF. So I go from the beginning to the end. That's going to be EF. It's kind of like connect the dots. So my vector EF is all of these multiplied, or all of these added together. Now try these last three on your own. Well, these ones are subtraction, so these might be more difficult. So let's take AC, and we're going to subtract FG. So FG is here. So instead of going this direction, we're going to go that direction. So it's going from here to there. So if I'm subtracting FG, it's like going from G to F. So AG is going to be my answer. Now FG minus GD. FG is here. If I subtract GD, that means I'm going from D to G, which if I put that at the end of this one, it would look like this. So that would go from F to A. Now if we have AB, line this up, AB minus BD. BD is here. So if I subtract BD, now this gets kind of weird. I'm going to pull this down so we can see what happens. So subtracting this is like putting this one up here. So I'm going to start at A and go way up here. Now you might think, there is no possible answer in this where that's true. Well, what factor would be equivalent to that? Well, look at that. EB is the same exact vector as these two when they're subtracted. So the answer will be EB. That one was a little tricky. All right, let's see if you can do the homework. Good luck.